When you give a large Go codebase to an LLM, the context window fills up fast. Most of what you send is noise. PureAST extracts only the relevant signatures, types, and dependencies in a deterministic, composable way. Today we will walk through the design, the library internals, and then run it on the Go standard library to see what real output looks like. We start with the central type, a record of sets, types, functions, structs, interfaces, imports, constants, and variables. Nothing fancy yet. The interesting part is what we do with it. The constructor returns the empty value. This is the identity element of our monoid. Composition starts here, with nothing. Now we declare the monoid, a type with an identity element and an associative combine operation. Empty gives nothing. Combine merges two values. That is all. The combine operation merges two dependency sets by combining each field with the underlying set monoid. Because sets compose under union, dependencies compose under union, the math gives you correctness for free. Now the second key abstraction. A visitor is a function from dependencies to dependencies. An endomorphism. It takes accumulated dependencies and produces new accumulated dependencies. Two visitors compose by running them in sequence. The composition is just function composition. Because a visitor is an endomorphism, composing visitors is also a visitor. The category closes. Here in the extract package, the visitor type is the same shape. We use an endomorphism monoid from pure kernels for composition. The extraction algorithm becomes a fold over the AST that emits visitors and combines them. The first function walks a Go expression and returns a visitor that adds the right dependencies. It never mutates anything. It returns a function. The actual work happens later, when you apply that function to a starting dependencies value. The next function extracts a function declaration. It composes smaller visitors, for the receiver, the parameters, the return types, the body, into one visitor. The whole AST traversal is built from these small composable pieces. The next monoid lets us combine extracted files. Empty is the empty file node. Combine merges two file nodes by combining their dependency sets and concatenating their declarations. Now the payoff for purity. This function walks a whole directory, parses every Go file in parallel, and combines the results with the monoid. Because each step is pure, parallelism is free, there is nothing to synchronize. Now the application. The dump command is the LLM Context flagship. Given a package, it emits every top-level symbol, structs, interfaces, type aliases, functions in compact form. The constructor wires it up. The default output is signatures only. Bodies are stripped. The result is always syntactically complete Go, because the pipeline is symbol-aware. It drops whole declarations rather than slicing through one. The final renderer produces the output text. You can pipe this directly into a Claude prompt or fit it to a token budget. That is PureAST. Now let us see what it actually does on real code. Here is the entire Go context package, dumped through PureAST. The original is 800 lines. The output is 331. This is the central interface, the heart of every Go server, the root context, the simple constructor. A child context with a cancel function, then a child context with a deadline, and one that carries a key value pair through the call chain. That is the entire context API in 5 functions, fits on one screen and you can paste it into Claude as is. The I/O package is interesting. Original size 1100 lines, dumped size also 1100 lines. PureAST barely shrunk it because I/O is almost entirely interface. There are no implementation bodies to strip. What you see is what you get. Here is the reader, here is the writer, here is the closer, and the combined read-writer. These are the foundational interfaces and every other Go I/O type satisfies the shape of the language. Now net/HTTP. The original is 30,000 lines. PureAST cuts it to 9,400, 3 times smaller. Here at the top, the client struct, with transport jar and timeout, the whole API surface you actually use. Here is the request type, every field documented, no implementation noise. Here is the response. Here is the server, and every method on these types is signature only. Thousands of lines of HTTP machinery distilled to its API surface. Here is the handler interface, the thing every web framework in Go is built on. Right there, 3 lines, complete contract. Now sync. Here is the mutex. Here is the once primitive. Here is the read-write mutex and the wait group. Every concurrency primitive in Go, in 1/5 the original size. This is what you send to an LLM when you want it to reason about Go routine coordination. To wrap up, Here is how PureAST itself runs. The main function, a standard root command pattern, you install it with go install, then point it at any package. Your code, your dependencies, the standard library. The command that produced everything we just saw was PureAST dump, followed by a path. That is it. Functorial design, sound algebra, real-world impact.